Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top or the bottom of your screen. Wherever your Zoom controls are, you should see a Q&A button. Click on that, type in your question, hit submit, and I'll get to those at the end of the session. If you're watching along on YouTube, just feel free to use the live chat function there, wherever it is on the screen that you're using, and I'll get to those questions and comments a little bit later as well. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple of years as a diagnostic sales rep with Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So I worked at a dealership, and over time, I guess, just became the default diagnostic guy in the shop. So always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come in my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is anti-lock braking systems, operation and testing. Finally talking about ABS. We talked about speed sensors a few weeks back. So now we're just going to kind of continue the next progression, and we're going to talk about ABS and traction control, vehicle dynamics. They're all sort of interrelated. So we'll cover a bit of those throughout this course. So first off, a little history. We're going to talk about where it came from, and we can see where it's going as well in the future. System overview and differences between the different styles of systems that are out there, multiple channels, so on. We'll talk about different components in the system and how they operate, how they work, kind of give you a good overview on that. Then we'll talk about component testing and also some scanner functions that we may need to use for it, etc. So first off, a little bit of history. So ABS has been around for a lot longer than you might think. It was originally introduced for airplanes back in the 20s. So after World War I, they guess they needed to figure out a way to get those wheels from locking up on landing. So they came up with ABS in the 20s. Modern automotive systems came about in the late 60s, early 70s. So Ford's SureTrack system was the first mass market one. Came out in 1969, and that was standard on all Ford vehicles in 1971. And then Toyota had the first computer-controlled anti-lock braking system in 1971 as well. And then, of course, we've seen how it's progressed over the years. And also motorcycles. Don't forget, motorcycles have ABS on them now, too. BMW was the first manufacturer to put ABS on their motorcycles starting in 1988. And now most of them have them, I would say. So overview of the ABS systems. Usually uses 3 or 4 wheel speed sensors. Depends on the vehicle. Some use 2, and we'll see that in a second. But usually 3 or 4 on a modern vehicle. We also need an electronic control unit. So you're going to have your ECU, your ABS ECU, that's going to control the whole system, looks at the sensors, makes decisions. Hydraulic pump and solenoids, that's what's going to release the caliper and actuate the caliper as it is trying to pump the brakes, so to speak. It's not really, it's simulating pumping your brakes with your foot, but it can do it way, way faster and way more accurately, and it allows you to keep control of the vehicle, allows the vehicle to not skid when I'm trying to maybe turn a corner or something of that nature, or icy road. Icy road, there's not a lot that it can do, but a slippery road, something of that nature. Modern systems can apply and release that brake 15 times a second, so it'll actuate and pulse those brakes 15 times a second. It's kind of crazy how fast that can be. So the different system types that we'll see out there. So we talk about sensors and channels. So one sensor, one channel, which they really don't use anymore, but that's a one wheel speed sensor and one channel for brakes. So when they say a channel, in this case, it would be the rear brakes on probably a pickup truck is usually where that was most commonly found. So you'd have a rear wheel speed sensor on the axle usually, and then the one brake channel, and it just controls it, turns it on and off. For the rear wheel only ABS, like it says mostly on trucks. Then there's 4 sensor 2 channel, because most vehicles nowadays have 4 sensors, but maybe it only operates the front and rear separately. So as it says there, it was early automotive applications. It's going to operate the front and rear as 2 separate brake channels. So the front 2 would be together, the rear 2 would be together, and it just actuate them separately. 3-sensor, 3-channel would be on a truck with 3 wheel speed sensors. So you'd have 2 independent front wheel speed sensors plus 2 independent brake channels. And then the rear wheels would be tied together. So you'd have a T somewhere on the line, and with the rear wheels would be tied together and actuate together. Then you get 4-sensor, 3-channel. So that'll be the front wheels are independent and the rear wheels are together, but using 4 wheel speed sensors. And then 4-sensor, 4-channel would be all 4 wheels can be operated independently, and there's 4 wheel speed sensors on the vehicle as well. So most cases nowadays, you're going to find 4-sensor, 4-channel. Could be 4-sensor, 3-channel, depending on the vehicle. Like I said, that's usually mostly on pickup trucks that have the separate 1-speed sensor in the rear on those vehicles. Speaking of speed sensors, if you saw my speed sensor class a few weeks ago, we talked about it in great detail. So if you want more detail than I'll give you here, you can go check that one out. I will just do a little overview here. We have 2 different speed sensors that we're going to deal with for wheel speed. 2 main types we're going to deal with for wheel speed. So the older style, I guess you could say, the passive style, it's going to be a coil of wire around a iron core with a magnet, and it's going to read the metallic rotor wheel that's going to go by. And it's going to, this generates a magnetic field. And as the rotor goes through that magnetic field, being metallic, it's going to change the magnetic field in a way. And that generates a pulse, generate an electrical pulse that will go to the computer, and it'll read the wheel speed at judging by how fast the pulse happens. On most newer vehicles, they're going to use an active sensor. So it's going to be a magneto-resistive element. In this case, we have 2 magneto-resistive elements, and it goes into it's got an integrated circuit. And in pardon me, there we go. Instead of having the magnet be in the sensor, the magnet itself is in the rotor. So it's inside the bearing race mainly. It's usually when you see those hub assemblies, it's going to be in there, and it's going to have alternating north and south poles all the way around it. And that'll be what we call an encoder ring as it goes around. As the magnets go by, the magnetic field goes by these magneto-resistive arrays, it will generate a signal, goes to the sensor, and then the sensor will send a signal down the wire. And usually on these, it's not a huge signal. It's a very small voltage. Usually it's a volt or less quite often. And this also allows them to pick it up on a much slower speed. So with the passive type, it requires a much higher speed to get going, to get a signal started. So you can operate at a much, much lower speed with the magneto-resistive elements. So with that magneto-resistive sensor, as I said, it has the ring that goes around the outside. And what this gives the manufacturer is the ability to also sense what direction is the vehicle going, because that can help operate the system more effectively as well. So if it's going forward in this example, we see the North Pole is there, and the ring is going to be the same, it's north, south, north, south. So the North Pole hits the A sensor first. So that is going to go high, and it's going to give a sense here. And then it puts out a square wave. And then when the B sensor hits it, that also would generate a square wave as well. So you're just going to see a single square wave like this as it moves forward. As the vehicle moves backwards, the B sensor picks up on the North Pole first. So as that goes by, going the other way, that will send out a signal first, and then the A will send out another signal, and that gives us a modified square wave over there. Now, why would a manufacturer, why would a car want to know, is it going forward or is it going backwards? Is due to the weight shift. So if I'm going forward, I know I need to apply more brakes to the front because the weight of the vehicle will be towards the front. If I'm going backwards, same thing. So more weight needs to go to the rear of the vehicle, or more braking pressure needs to go to the rear of the vehicle, because that's where all the weight is going. So many manufacturers nowadays, especially on these modern systems, are able to discern whether or not they're going backward or forward for that. So they can actually get pretty darn fancy. So here's an example on a 2019 GMC Acadia. So a wheel speed sensor in this case is one of those digital sensors we just talked about. The electronic brake control module sends a 12-volt reference voltage signal to each wheel speed sensor. As the wheel spins, the wheel speed sensor produces a square wave DC signal voltage. The wheel speed sensor increases the signal frequency as the wheel speed increases, but does not increase the signal amplitude. So we'll see when we test it what it would look like. It's going to tell us that they're at each hub. And we're going to test it at the wheel speed sensor connector as well. And they'll give you a pinout of each of the connectors here. This is an archaic component test module. It's going to tell you how that looks. And if we go down to the bottom, it gives us a known good pattern as well. And as it said, lab scopes should be used to check the waveform. It's not a huge voltage range. It's going 0.6 to 1.6. That's not very much at all. And it'll generate a square wave. Depending on how fast the wheel is spinning, will depend on how close together those square waves are. So as we said, the frequency changes. The amplitude does not change. So the frequency will get faster or slower. So it'll be closer or further apart as it goes, depending on the speed. And that's how the computer judges the speed. There's also a tip on this particular vehicle, a tech note. So there's some DTCs, C codes, so chassis codes could set, and we could have ABS, service traction control system, and or service StabiliTrak, depending on how the vehicle is equipped. And this may be caused by bits of ferrous magnetic debris stuck to the wheel speed sensor magnetic encoder ring. Remember how we said that encoder was magnetic? So if I have some iron filings, maybe I get some rust going on underneath the vehicle, because that happens all the time. It's going to get stuck on that encoder ring, and then the sensor can't read it as well, and it will cause issues. It says you can use just a soft, like a nylon bristle toothbrush. Don't use anything magnetic, like a magnetic pickup tool. I'll just wipe that off with the magnet. I'll just take all that. Because if you do that, that could damage the magnet inside on the rotor there. So you want to make sure you're cleaning it with just a soft nylon brush, mild soap detergent in order to clean that off. And then here's a representation of what that might look like on a vehicle. So we have the encoder ring there, and we have the debris around the outside. And this is from a GM bulletin on that as well. There's also another bulletin on a Volkswagen Passat, and I'll show you this full bulletin a little bit later when we go live on the tool. But what happens is the wheel speed sensors on those vehicles, like like 2012 to 2015, they say is where the bulletin applies to anyways, that the speed sensors are not swappable. You don't swap them side to side, because if you do, they will hit. So in this case is where you can see where it rubbed in on the encoder ring, and then there's the encoder ring there, all worn out, and it just wears it down and destroys it. So that would need a whole new wheel hub assembly, wheel bearing assembly, and then new speed sensors as well. So that could cause an issue, could cause a code, and then it could just be from, well, let's swap it with the other side and see what happens. We don't want to do that on that Volkswagen Passat, because that could be a very bad thing, and you could have two broken ones in that case. And here's just another example of that type of speed sensor. This is on a Dodge Charger. So it does the same thing, except it's a slightly different square wave. So in this case, it says to produce a square wave that varies by about 400 millivolts. That's it, 400 millivolts. So it goes negative 0.2 to 0.2. It varies on both sides. And this was spinning the wheel by hand, so you can see it's a little bit jerky there as well. So it should just go between 10.4 and 10.8 volts. And this is just showing you the difference. It's AC coupled there. So with the AC coupling, it centers it around 0, and then it just shows the difference in the pattern on either side when you do that. So that's just another example of one you might see out there, especially on these new systems. Also need a hydraulic unit. So we'll talk a little bit more about how this works. So we have a pump over here. We have a couple of accumulators and a bunch of solenoids. We have 2 different types of solenoids for each wheel. So there's actually 8, 9, 10, 11, 12 solenoids in there in this pack. But that's the control module, that's the solenoid pack, and then that's the pump, and then assembled without the control module anyways. Looks something like this, and there's 4 channels there, as we can see. Now, not every vehicle is going to look exactly like this one. I believe this was a TRW unit. Just depends on how the manufacturer made it, but you'll have brake lines coming in there, and then you'll have the computer. Sometimes the computer will be separate. Sometimes the computer will be integrated to it, like this one is, and then these are all the solenoids and accumulators there. So how it works, we found this animation on YouTube, and basically how it works, we have a wheel speed sensor down here. And when the vehicle or the computer notices that the wheel is slipping, slowing down, or going to lock up, that it'll close it off and maintain the pressure on the wheel. So as you can see, it's sending a signal down to the coil and the solenoid, and half the solenoid closed. So we're not getting any more pressure. Now, if it continues to slow down, what we're going to see is it'll send additional current, and it'll start the pump as well. So here's the accumulator, here's the pump, and then it opens this other chamber down here by increasing the amount of current flow into the solenoid, which allows it to bleed off the pressure from the brakes to allow the wheel to start spinning again. And this is what you would feel in the pedal. If you've ever driven a car and actuated the ABS, that's what you feel in the pedal is the fluid going back into the master cylinder. So that's what you feel kicking back at you. So you just want to always maintain constant pressure on the brake pedal, and then the vehicle, the solenoids, the accumulator, the pump, all that will pump the brakes for you, so to say. You don't want to pump the brakes on an ABS vehicle. You just want to hold steady pressure, and you'll feel it vibrate in your foot, and you'll hear it too. So just if you've never driven a car and they've had it actuate, it feels a little odd the first time, but that's how it works. So it has the solenoid valves in there, the accumulator and the pump, and then has some check balls in there as well. So it's able to bleed off if it needs to, or it can maintain the pressure. Once you apply the brakes, it'll maintain the pressure until the wheel starts to skid, and then it'll release the pressure. And it does that, as we said before, modern vehicles can do that 15 times a second. So it's kind of crazy how that works, but amazing the technology that we have. And just to keep the car safer. Other things to keep the car safer, though, is traction control, vehicle dynamics. You hear it called ESP. There's a bunch of different names for them. We're going to actually look at those in a second. But it mainly utilizes the anti-lock brakes in order to help us get the vehicle where it needs to go, and also with traction. So if the wheel starts spinning, it can also apply the brakes in that case to allow us to get traction. So it uses the ABS as well as other additional sensors that you might find. So they have a yaw rate sensor, or it could be a multi-axis acceleration sensor, depending on how the manufacturer equips it. We use a steering angle sensor, steering effort sensor, multitude of other sensors and systems on the vehicle, and it kind of combines them all together. In order for traction control to work, as I said, it modulates braking to gain contraction on slick surfaces. So it could be snow or sand, or if you're trying to do a burnout, you do need to disable the system in order for that to happen. Also, just thought about this too, that brings me to this point. If you are trying to test wheel speed sensors or test the system, and you want to make sure it works, if you need to drive the vehicle in the air, you need to turn off traction control if you can. Otherwise, it's just going to lock the brakes up. It's not going to work. It's going to think the wheels are skidding, right? So it's going to lock the brakes up. So you need to make sure you turn off traction control, VDC, whatever it happens to be. And then it helps modulate the vehicle to control the vehicle skidding or rotating, flexing, what have you. So here's just another example from that GMC. This vehicle is equipped with a TRW EBC 460 brake system. So it's good that they kind of tell you all the different ins and outs of the system. The electronic brake control module and the brake pressure modulator are serviced separately. So in this case, you can have a separate module from the modulator assembly. So if you only need to replace the computer, or you only need to replace the solenoid pack, you can do so. The brake pressure modulator uses a 4-circuit configuration to control hydraulic pressure to each wheel independently. So this would be a 4-channel, 4-sensor system, which is also good to know. If I'm trying to diagnose this, I need to know, is it 3 sensors, 4 sensors, how many channel? Depending on the options, the following vehicle performance enhancement system are provided. So depending on the vehicle fit, vehicle trim level, you're going to have ABS, traction control, stability control, dynamic rear proportioning, where it proportions the brakes dynamically, and hence the name. Hill descent control system, so that might work on the brakes going downhill, or hill hold start assist if we're trying to go up a hill and we have either a manual transmission, which is almost impossible to find nowadays, or some CVT vehicles can be bad about that too, rolling a bit. So it needs to know what gear it's in, so to hold the hill before you start taking off. Cornering brake control, hydraulic brake assist, optimized hydraulic braking system, intelligent brake assist, trailer brake control system as well, and trailer sway control system. So all of those different systems utilize the analog braking system on this electronic brake control module. So you can see it's more than just ABS. There's a lot of other systems that depend on it. And then it talks about the following components that are in there. So the electronic brake control module controls the system functions and detects failures. It supplies voltage to the solenoid valves and the pump motor. The modulator, which is where the solenoid valves are, contains the following components: brake pressure sensor, hydraulic pump with pump motor, 4 isolation valves, 4 dump valves, 2 traction and stability control supply valves, 2 traction or stability control isolation valves, a high pressure accumulator, and a low pressure accumulator in there. So it gives us all of these different components just inside that one modulator unit that we saw. If I go down a little further, it also utilizes the body control module because it monitors the brake pedal position sensor signal when the brake pedal is applied and sends a high-speed serial data message to the electronic brake control module. So we're going to deal with serial data as well. Brake pressure sensor is used to sense the action of the driver application of the brake pedal, senses the pressure of the brake pedal. The sensor provides an analog voltage signal that will increase as the brake pedal is applied. And then it monitors the brake pressure sensor as integral to brake pressure modulator. So we don't have brake light switches so much anymore. It is more of a brake pedal sensor, pedal position sensor, and or a pressure sensor in there as well in most vehicles. So, and then it sends a signal to the body control module, then to turn on the tail lights. So it's not just the direct, putting on the brake lights. Instrument cluster as well is going to display the vehicle speed, as well as any of the engine light or what have you. Multi-axis acceleration sensor will read the yaw rate, lateral acceleration, and longitudinal acceleration sensors all in one unit. We'll talk more about that in a second. Multifunction switch to turn the traction control on and off. We're going to use the steering wheel angle sensor to know what angle we're in and what desired driving direction we need to go in, which is why it's imperative that you reset the steering wheel angle sensor if you ever replace it. Transmission control module, it needs to know what gear it's in so it can help with that, and the hill start assist or hill hold. And then in the active wheel speed sensors. So electronic brake control module uses the frequency of the square wave signal to calculate the wheel speed. So all of these things work in unison to drive that vehicle down the road, right? Just to make sure we don't crash into anything when we're using the brakes or making sharp maneuvers. So the yaw rate sensor, we talked about the multi-axis sensor as well. Yaw rate sensor is really going to cover this, right? So how's the vehicle yaw? So the yaw would be the front end. Which way is it going? So in this case, we're looking at a 2011 Forester, and that has a yaw rate sensor in there. It's built in with the in the center of the vehicle. The yaw rate NG sensor detects changes in vehicle direction. It detects the motion by moving electrodes built in the sensor. Sensor will send ABS control unit a signal by change in voltage. Hold on one second. I got somebody spamming my YouTube here for a second. I'm just going to remove that. There we go. You're in timeout. Okay. Anyways, back to this. So the sensor will send ABS control unit a signal by a change in voltage. So it's going to have 4 pins on there, power, VDC off switch will turn it off, and then CAN communications. That one communicates over the CAN bus. So you're not going to be able to, on many of these sensors, you're not going to be able to test them directly with a scope unless you want to look at the CAN bus and see if the CAN bus is working. I suppose it's about all you can do. It is located in the center console next to the parking brake assembly, and you do have to remove the console top trim to access the sensor. All right. So in this case, so the output test of that yaw rate or G sensor that they use. With the value, with it installed on level ground, it should read -4 to 4 degrees per second on yaw, or -1.5 to 1.5 meters per second square on G sensor. Then they would want you to unbolt it and then tilt it 90 degrees forward, 90 degrees backward, to the left, to the right. And it should read 6.8 to 12.8 meters per second squared when you're doing that. So that's how you test it. You're going to test it by looking at data, scan data, and seeing how it's moving. All right. So no real test unless we're looking at CAN bus. Then back to the GMC. This one has the multi-axis sensor. So yaw rate and lateral acceleration sensors are combined into one multi-axis acceleration sensor module external to the electronic brake control module. So it is in the passenger compartment underfloor mounted center console. So these, in order to know what angle the vehicle's on, it's helpful to have it towards the center of the vehicle. The multi-axis acceleration sensor output signal is part of serial data to the EBCM. If power and ground to the sensor are okay, check the signal circuits for high resistance, open or short to ground or power, and a DTC may be set indicating the type of fault as well. So it has supply voltage, low reference, and once again, CAN, high and low. So if you want to check the CAN, you can. And really the only test we can do on it is a DC voltage test that's checking the supply voltage. So it should have supply voltage and the ground should be okay too. Steering angle sensor, going to measure the angle of the steering wheel. So am I 360 degrees or 720 degrees, or where am I as far as the steering angle on the vehicle? Sometimes they're on the top, at the top underneath with the clock spring there. Other times they're at the bottom, and they also could be combined with a torque effort sensor as well. So if you want to learn a little bit more about those types of sensors, I did a class on chassis electronics. It should be in there with the electronic steering rack and things like that. So it uses all of these inputs in order to control the vehicle going down the road. All right, so let's go live on the tool. All right, so here's the Zeus, and we're going to walk through a few things. Now, first thing I want to walk through some guided component test information. So if you have a Zeus, a Verus, a Verdict, a Triton, a Modus, or a Vantage, any of those tools will have the built-in guided component test function. If they have the scope and test meter, it's going to be in there. So in guided component test, though, if you want some more information on what we're talking about here, there are classes. So it's at the top of the menu in the latest software release. Sometimes it's down at the bottom. Sometimes it's somewhere else, depending on your software update. You want to stay current on your software, so it should be at the top. So we'll go to classes, and then if we go into how-to, down into the 20-minute classes, the very first 20-minute class is a 20-minute anti-lock braking class. So it's going to walk you through operation, basics, testing active wheel speed sensors, and testing inductive wheel speed sensors. So if we go into, say, operation of the system, it's going to tell you how it works. So the ABS system operates under 3 conditions: increased pressure, maintain pressure, and reduce pressure. And that's going to say hydraulic solenoid valves are used to control those states, etc. I'm not going to read through this whole thing because you don't need me to, but it's going to have it's going to walk through the 3 different stages as well. And then how to test. So inductive wheel speed sensors is going to be your analog holder style. And then the active wheel speed sensors is going to be your square wave, your digital style we were talking about there as well. So once again, that is under classes and how to, and then it's a 20-minute anti-lock brake. All right, so let's walk through some vehicle applications. Whoa. First off, let's pull up that Passat we talked about earlier with the TSB. I'm going to go in my shop key first. This is just kind of wild. I happened to happen upon this bulletin one day doing research for something. Actually, it was on the wheel speed sensor course. So we go under TSBs, and we're going to go down to brakes, braking control system. And there is the ABS TPMS light on due to wheel speed sensor fault as a result of the front wheel bearing or wheel speed sensor swapping. Let's see. ABS TPMS light due to front wheel speed sensor swapping. This can be due to the encoder ring being ground down on the wheel bearing hub unit, resulting in a damaged part. Cause: damage from swapping the speed sensors left to right or vice versa during diagnosis. So as we can see, it goes in a little bit too deep, and we can damage the encoder ring. So you can see that right there. And the tip is discontinue the practice of swapping sensors from side to side during workshop diagnosis. Hey, did it break when you did that? Don't do that. Right? That's Volkswagen's fix to that. So that's actually a tech tip. All right, so discontinue the practice of swapping sensors from side to side. Very good. So just don't do that. If you have a 2012 to 2015 Passat, do not do that. Okay. So let's go into guided component test here as well. And we have ABS, and we have the ABS module, the system description, etc. So let's just go into the description. Let's see how this particular vehicle works. So the ABS system is used to regulate brake fluid pressure to each wheel in the case of hard braking. By regulating pressure to each wheel in the hard braking event, wheel lockup can be prevented and damage can be prevented. Typically, the ABS system is used to regulate brake pressure at the rear axle, similar to a proportioning valve, to prevent the rear wheels from locking up too early. However, Volkswagen does not use a mechanical pressure regulator on the Mark 60 or Mark 70 ABS systems. Conversely, the ABS module is programmed to regulate pressure to the rear wheels on braking. If the light's illuminated, the rear wheels may lock up earlier than expected. These vehicles are optionally equipped with ESP, so that's their version, so electronic stability program. It works in conjunction with the ABS to provide traction control and stability control to the vehicle. The ESP module accomplishes this by controlling braking pressure and engine torque to aid oversteering, understeering, acceleration. These vehicles are also equipped with a hill hold feature. So in this case, it's hill hold. It's controlled by the ABS module activating the solenoid valves to increase brake pressure at the wheels. This prevents the car from rolling back when the driver removes their foot from the brake pedal. The hill descent feature aids drivers while descending the hill without the wheels locking up and when driving on loose, rough, or slippery surfaces. The ABS module will increase, decrease, or maintain pressure at each wheel to prevent wheel slip. So I know that this vehicle has all of those things. So we can go to the module. First off, we can look at the location. So it's the right front of the engine compartment attached to the vehicle bulkhead. And then we have a pinout for that. So if we need to test anything, it's going to give us the pinouts of that whole module. Brake light switch. In this case, it is a switch that sends signal to the over the CAN bus, and it will apply and extinguish the brake lamps in that case. So it's basically a sensor for the brakes. I'm going to do a DC voltage and a resistance test there as well. Does a CAN bus test because we have to operate over the CAN bus to do that. Powers and grounds, wheel speed sensors as well. So front wheel speed sensor component information. It's going to say two pin sensor. It's a Hall effect type switch that measures vehicle speed by measuring a reluctor wheel located at each wheel. As the wheel spins, a digital square wave signal is produced, so we know that's a digital sensor. There's no separate signal wire. The signal is superimposed onto both signal wires. ABS module uses the signal as a vehicle speed input and by monitoring the wheel speed sensor signals can detect wheel slippage. Signal may often also be used for cruise control. So a lot of good information there. Let's go to a different vehicle. So that's going to be this guy right here, Nissan Murano. That's going to operate a little bit differently in the ABS. So the module gives us connector pinouts again. Stop lamp switch. So it's a double pole, single throw, momentary design. So this is an actual switch again. When the brake pedal is released, the switch plunger is depressed and the switch contacts are open. As it's depressed, the switch plunger extends and the switch contacts are closed. Simple system, just like the old days. Oh, this one has a vacuum sensor in it. So that's why I wanted to show you that. Component information. The brake vacuum sensor monitors vacuum in the brake booster. This is wired directly to the ABS module. Sensor output is analog DC voltage that will change with increase or decrease in vacuum inside the brake vacuum booster. So it needs to know how the vacuum is doing on the brake vacuum booster for the brake vacuum assist. We have DC voltage test on that. And then we have wheel speed sensors as well. So in this case, that's also a Hall effect switch and no separate signal wire. The signal is superimposed onto the ground wire as well. Metal debris and loose sensors can cause an erratic signal. Harness is easily damaged during brake service, so don't break it when you're doing the brakes. And then last one we'll talk about is the Tahoe. 2018 Tahoe Premier. Fancy one. This one has, we go under ABS, a brake booster vacuum sensor as well. Brake fluid level switch, brake pedal position sensor. Once again, it's not a brake switch. It is a pedal position sensor. So the engine control module monitors the brake pedal position sensor and other sensors to determine if reduced engine torque is needed to assist in lowering vehicle speed. The brake apply sensor is in the same housing and is for the body control module to turn on the brake lights. So see, we have two sensors in there. One signal goes to the brake control module. One signal goes to the body control module. Both of the sensors work the same way. When the pedal is released, the voltage would be about 1/4 volt. And with the pedal fully applied, the voltage would be 4.75 volts on the signal wire. It's under the driver's side of the instrument panel, connected to the brake pedal, as makes sense. So we got a low reference, 5-volt reference, the stop lamp signal, brake apply sensor signal, low reference to 5 volts. So you got two sensors in there running 3 wires. So that's a little different. CAN bus, electronic brake control module, grounds, multi-axis acceleration sensor on that one as well. So this one actually does have a DC voltage test, and we're just testing powers because that is high-speed data as well. So positive and negative high-speed data. Parking brake switch, wheel speed sensors on this one should be the same. Yeah, 12-volt reference signal, and it is a digital square wave on that one. Also on this, though, there's something I learned the other day. Okay. So on this vehicle, and many other vehicles. But on our scan tool here, we got a service resets and relearns. So on this vehicle, when you replace the brake pedal switch, that switch we were talking about, you need to relearn it in 2 modules. You need to relearn it in I think it's the ECM and the BC or the brake control module and the body control module, right? Because we have the 2 separate switches. So you'd have to know that first, and then secondly, you'd have to go find them, right? So you have to go into different modules to find it, and there are a lot of modules on this vehicle. Now, luckily, they are categorized on our tool. But another thing that we add that's going to save you time in that regard is going to be the service resets and relearns. People ask me about the service resets and relearns all the time. It's like, how is this going to help me? For one thing, so if we think about going down to the brakes or the brakes down here, there we go, and then we have replace or relearn the brake pedal position sensor. So I'm going to go in here. There we go. It's going to give us some top repair data if we have it. It's also gives us access to TSBs and then functional resets and calibrations. If I click that, it is going to pull both resets that I need from both modules and put it on one screen. So I don't have to go through a couple different modules. That is a huge time saver just by clicking that one button. It's going to bring me both relearns on the screen here. Somebody asked me this the other day. I'm like, you know what? I'm not really sure. So now I know. So we go in here. It's going to do a little reset for us. All you have to do is hit learn and it'll learn it. Procedure complete. And then we go into this one. And it'll tell us the learn procedure as well. Now it's got a little bit more data going on, but then we go into learn and it learns it there, test complete. So instead of having to dig through and find other modules or the modules that they're in, dig through the output controls or the tests that we need to do, we simply can go into service resets and relearns menu and go through it that way. So that I think that's really a cool add that people don't always necessarily think about. If I have to reset multiple things in multiple locations, it's all there in one place. I just thought that was really interesting when I learned that the other day. So I figured I'd pass that on to you, and it was very timely that I learned it back that a couple weeks ago too, because this class is coming up. So I thought that was pretty cool. So with that, that is my time for the night. Let's talk about next week. We got another all new class next week. Next week, we're going to talk about driver comfort systems. So what in the world are driver comfort systems? So the way I categorize this is these are the things that you really don't need, but they're nice to have. Things like heated and ventilated seats, heated steering wheel. How about noise cancellation systems inside the cabinet? It sends out a signal that cancels the road noise out of the vehicle. Sound generation systems. We've talked about that in the hybrid and electric vehicle class, where there's sometimes they generate a sound. Or electronic motor mounts. I thought that was really wide. That's been around for a long time too, electronic motor mounts. Try and diagnose a vehicle that maybe has a drivability issue without turning off the motor mounts. And the vehicle might not be shaking. You might not even know there's a problem with it. So we're going to talk through all those different systems next week. So same time, same place, 6 and 9 Eastern. If you want to join me on Zoom, go to snapon.com/OT. If you want, the 6 p.m. class goes to YouTube, so youtube.com/SnapOnDiagnostics. If you're watching me on YouTube right now, thank you. Make sure you give a thumbs up to the video, and also make sure you are subscribed. We find that many people watching these live streams are not subscribed, and we definitely appreciate it if you did. And you'll get a notification anytime we post new content. We got a lot of new stuff coming down the pike over the next few months, so definitely want to keep abreast of that. That would be the way to do it. The 9 p.m. Eastern one also goes to my Facebook page. So it is facebook.com/SnapOnJason. If you want to watch over there, give me a follow, check it out there. Also, if you want to see any of the other previous topics we've done on these live streams, things like ADAS, data bus testing, etc., you can go to our YouTube channel, youtube.com/SnapOnDiagnostics, and check it out over there. There's a playlist. This will be episode 48. I can't believe I'm almost at 50 episodes already doing this. So pretty cool, pretty crazy, but it is all free. It's all free. And if you want to ask the questions, it's good to watch live. You don't always have to watch live. You can always watch it later. It looks like I got a couple questions, but before I get to that, I also want to make sure you know about my buddy Al too. Al also does free diagnostic training 3 nights a week. So he does Monday on Apollo, Wednesday is on Zeus, and Thursday is on Triton. So if you want to learn more about your tool, how it works, how to set it up. So he goes through talking about how to set up the Wi-Fi, because Wi-Fi is critical nowadays for a lot of different functions on a lot of different vehicles, not just Chryslers with secure gateways. So a lot of different functions need that Wi-Fi on. So we talk about that. We talk about setting up your free Snap-on Cloud account so you can share files with your customers. And also he walks through code to completion on intelligent diagnostics, fast track intelligent diagnostics. How does that help me as a technician diagnose cars faster? It's going to save you a ton of time by automating a bunch of things. So he walks through that as well on a real life scenario. So that's about an hour, and that'd be the Apollo class. And then on Wednesday and Thursday, since the Zeus and Triton both have guided component test and meter functions, he takes about a 5-minute break in the middle and then goes through the scope and meter functions on the tool with real world examples as well. So same time, same place, 5 and 8 Central, 6 and 9 Eastern. Go to snapon.com/OT. You can save yourself a seat over there. All right, let's get 2 questions. I got one on Zoom. Let's see. Conrad asks, I usually don't do the alignments at my shop, but do you have to relearn the steering angle sensor after you do an alignment? Absolutely. You would want to change that steering angle sensor after you do the alignment, because it's learned to however the vehicle might have been going before. You know how you definitely have to make sure the steering wheel's straight too. But that's just another thing you would need to do is the relearn on the steering angle sensor as well. Absolutely. So that'd be on the list of service resets as well. All right, we got quite a bit on YouTube here. Let's see. Let's see. Ram 50 V8. Hello. Hello from Ukraine. I actually translated your name earlier, but I forgot what it translated to. I think it's Alexei Kanashevich. Maybe. Hopefully I got that right. But hello from Ukraine. Thank you for stopping by and joining us. Quinn Hall 24. Hello. Nick from the UK. Very thankful for all our training. Thank you very much for attending all of our training. I'm very thankful for you. Abel, thanks for checking in. Thank you for coming as always. Ram 50 V8. Remember back in the early 80s when the local police department got their first ABS cars? Lots of accidents until they learned to stomp and steer. Yeah, I could see that, right? So as I said, you don't want to pump those brakes on an ABS car. You definitely want to be able to just hold it steady. And let's see. Brian Lamontagne, thank you. Thank you. He says he always learns something new when watching. So I appreciate that. I appreciate you watching. We always hope to learn new things every day as we're going. So if you can learn a few things from me, I definitely appreciate you taking your time to learn stuff. With that, thank you very much, everyone, for attending. Oh, I got another question. Let's see. Gerardo says, so on Smart Diagnostics on Zeus subscription is supposed to update ends as updates. So you will get, if you're on a subscription on a Zeus, you will get an automatic update every time we release. We still do those every 6 months updates. The Fast Track Intelligent Diagnostics updates much more often every month or so. We do an update on the Intelligent Diagnostics. So with that constant access with the subscription, you'll be able to get that. So it's not going to end the updates because we still do have tools that have updates and don't have Intelligent Diagnostics. So not going to totally end them, and you still get those 6 months updates, the major updates. Every 6 months as well. Victor on YouTube is asking how to watch on Zoom. I'll actually type it in. So let's see, Victor. Sure, there you are. Let's see, snapon.com/OT. And then you can sign up over there. So just Victor, head to that website that I just put in the chat, snapon.com/OT. And you can go sign up over there. I'm on the left-hand side of the screen. There's a little red icon or a little red thing that says click here. Just click on that, register. And then for Al's classes, same thing. He's just on the right-hand side of the screen. So I'm on the left, Al's on the right. And Susan says, thank you. Keep up the good work. Thank you, Susan, for commenting. Thank you for watching, as always. So with that, everybody, thank you for watching. I always appreciate the comments and the kind words. And hopefully, we learned a little bit about ABS this week and how to help us diagnose it a little bit better. I always say if you want to diagnose it and you want to make it work the right way, you need to know what the right way to work it is. So as long as you know how a system operates, you can diagnose it more effectively. So hopefully you can join me next week for the vehicle comfort, driver comfort systems as well. Enjoy the rest of your week. Enjoy your weekend and take care.